set of notes will complete the one that began with graphing rational functions. So we're just going to move on and do a later part of those notes, which will be adding and subtracting rational expressions. To add fractions, basically, what you do is you've got to have the same denominator, so same denominator. And once you have the same denominator, then you will basically add the numerators and keep the denominator. Don't do anything with it, you just keep that same denominator. And that's what these two examples say there in P's and Q's. So let's look at a few examples with variables in here. So you can see that in this one that we've got the same denominator, so we can't add them. We'll keep the denominator, 7c squared, and we'll just add the numerators, and 5 plus x. It's as easy as that. I'll look at it to see if it can reduce, and the answer is no, it can't. Moving on to number 2, again, we have the same denominator, so we can add them. We'll keep the denominator and combine the numerators. This is actually subtraction, isn't it? So that it becomes x squared minus 49. Now, when I look at x squared minus 49, clicks that is the difference of squares, and that perhaps it will reduce. So I'm going to factor my numerator into x minus 7, x plus 7. Denominator is x plus 7. And I see that it will reduce, and my answer is going to be x minus 7 over 1, which is x minus 7. The third example, again, we've got the same denominator, so we'll keep that denominator, 3y to the second. This is also subtraction, so notice what happens on this. I have x, and I'm subtracting that whole numerator, that second fraction. So when I subtract it, I need to put that in a parenthesis. So the numerator, x plus 1, the whole entire thing is going to be subtracted. So I will need to distribute that minus, and I'll get x subtract 1 over 3y squared. And that simplifies to negative 1 over 3y squared. And those are just some simple examples of adding and subtracting fractions. So on the next page, we'll talk about finding a common denominator. So you know, working with fractions, if they don't have the same denominator, then the first thing that we have to do is be able to find a denominator that you can make in common to both of them. And there's some steps that are listed here that you can take through. If two factors are opposites, factor out a negative 1 so that two factors are the same. And I'll step through these one by one with you as we go through. So example 4, I have 3x to the 5th y squared. I'm going to list the factors that are there. I need in my LCD, I need of one of each kind. So I have a 3. I can see that I have an x. I also have a y. So my LCD has got to have a 3, an x, and a y factor in it. When I move to the next one, I see that it's got a 5, so I need also to have a 5 involved in there. I already have an x and I already have a y. So I'm not going to repeat those. It's just going to be written once. So I have one of each kind of factor listed there. Then I'm going to compare in their original what their exponents were. For my x's, I have x to the 5th and x to the 1st. And I need to use the larger of the two. So x to the 5th will be my exponent for my x's. For my y's, when I compare those, here I have a y squared and a y cubed. The larger exponent is 3, so my y will have a 3 on it. So when I rewrite this, I will have 15x to the 5th, y to the 3rd, and that will be my lowest common denominator. Number 5 looks a little different. This time I have binomials, And when I have a binomial, I need to first factor it. So this will factor into x minus 2, x plus 2. And my second one will factor into, I'm going to take out a 3. That'll factor into 2 minus x. Now, I do notice that originally in my green denominator, I have an x minus 2, and in my red denominator, I have a 2 minus x. Those are opposites of each other. So what I'll do is I will take a negative 1 out of this. So I'm going to put it in the front. So there's my negative 1. Put my 3 next. And then my 2 minus x is going to become x minus 2. We can check that out, because those are the same thing. 2 minus x and negative 1 times x minus 2 is the same thing. So now when I find my LCD, I've got to have one of each kind. So I'm going to have an x minus 2, an x plus 2. I have a negative 3, so I'm going to put it here, negative 3. And x minus 2 has already been used. So I don't have to repeat it, that it's already been used. I check them all to see if there's any exponents, and the answer is no. So this LCD, I'd probably write the negative 3 first. Negative 3, x minus 2, x plus 2. Number 6, just another emphasis. X minus 1 and 1 minus x are the same but reverses. So we'll take a negative 1 out of that, and that's going to leave me with x minus 1. It turns that around. So my LCD for this would be negative 1 and x minus 1. And 7, one last one. I need to factor these because they're trinomials. So this will factor into m plus 6, m minus 5, and yes. And then my next one's going to factor into m minus 5 and m minus 5 using the AC. Oh, look, the m minus 5 is a repeated factor, so it's going to be actually written as m minus 5 squared. So when I find my LCD for this one, my LCD will have an m plus 6 and m minus 5. And when I look at the m minus 5 factor, I see that in the second fraction that I actually have an exponent of 2. And so that will include the m minus 5 squared for that. So that is it. I will have already told you if you needed to complete an assignment or just come prepared, and we'll work next class over this. Haven't decided yet.